Hello, and welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time, we talked about organizing our code into functions, classes, modules, and packages, and this time, we're going to be talking about containers. So, let's get to the objectives. Basically, we are going to be talking about Python's built-in containers, the list, the tuple, the set, the dictionary, and at the end, we're going to discuss NumPy arrays. So we've discussed all this stuff before, but this is more in-depth discussion. So a list is an ordered, indexed, changeable container delimited with square brackets. So it's ordered. Whatever order you put them in, that's the order you're going to get them out. It's indexed means you can tell it which index you want and it'll pull it out. Random access, pulling it out. All right, so if we say if fruit sub 0, our 0-based index is apple. Fruit sub -2, this is -1, this is -2. Fruit sub 1, now we can change the list. Lists are changeable. So we can now say fruit sub 1 is mango, which is fruit sub 1. So now we print it out and it's apple, mango, cherry, and orange. We can concatenate lists with the plus operator, just like strings, 1 + 1. We can say our fruits plus this array and so we did have apple, mango, cherry, and orange, and now we have apple, mango, cherry, and orange, and 1 none and watermelon. We can create substrings with the slice notation. So we give it 2 indexes, the from and the to. So this is starting at index 1 and going to index 3 minus 1. This n minus 1, so that'd be index 2. So this is from 1 up until 3, not including 3. So if we don't give it a starting index, it'll start at the beginning. If we don't give it an ending index, it'll start at 0, 1, 2, 3, and go to the end. Tuples. A tuple is ordered, indexed, and unchangeable container delimited with parentheses. That's how you know it. It's just like a list, except instead of square brackets, it has parentheses. So tuples are said to be immutable, but if you want to see why they're immutable until they're mutable, you can read this inventwithpython.com blog post from 2018. We already went through this in a previous discussion, and that was under, I think, chapter 2, using Python. Or was it chapter 3, language fundamentals, I believe. So same thing, you can index tuples, index 4, 0, 1, 2, 3, 4. And you can set it to 7. Oh, no, you can't. It's unchangeable. The so-called immutable type. So what are saying the difference between lists and tuples? Tuples offer some degree of safety. If we know that something doesn't need to change, then we can eliminate the risk of it accidentally changing, or perhaps a function changing it if we pass it as a argument. And if tuples contain only literals are used, they're much faster to create than lists with the same arguments. So if you run this from the command prompt, load the module, time it, and you give it this string to set it up. You say x is 1, y is 2, z is 3, and you do this 100,000 times, or 10 million. If you run this 10 million times, it will take an average of 0.03 microseconds. And if you do it with tuples, then it's 0.02 microseconds, a little bit faster. A set is unordered, unindexed, but it is changeable. So it's like a list, but you cannot have repeating elements. And we use curly braces just like dicts, but without the keys, just the values. So we can say, well, we can create a set with the built-in set function, and we give it an iterable object, and the string is an iterable object, so we pass it this, and the string is set to A, P, I, so it's not ordered. It doesn't stay in the same order we gave it into it, and notice we don't have two O's, we just have the one O. And if we pass it another iterable, a list, we'll get those three elements in our list, in our set. And if we try to duplicate elements, see, another way you can declare a set is with curly braces. So this is a set. It won't duplicate any items. Now we can run the union. So sets are just like they are in Python, just like they are in mathematics. So these three sets, if we take the union of those three sets, we'll get all of these elements. We get A, we get F. Remember, they're not in order, but they're all going to be there. And the same way intersection, if we intersect those three sets, the only elements common to all of them are D and E. See, this one does not have F. This one does not have C. And also the difference, we can say the difference is from set X. The difference of these two is A, B, C. So these two sets do not contain A, B, or C, but they do both contain D and E. So the difference is A, B, and C. Let's move on to dictionaries. A dict is unordered. Well, that's no longer true. Just realized in Python 3.5, dicts became, with the reference implementation in C Python, so Python written in C, dicts became ordered without any loss of performance. And that reference implementation became a language directive in 3.7. We're now in 3.8, but if you're running 3.7, it's all ports, Windows or Mac or Linux or anywhere else BSD, anywhere else you're running Python. They'll all as in Python 3.7, they are all going to be ordered. So you'll get them back out in the same order you put them in. And they are indexed with a key. And of course they are changeable, delimited like sets with curly braces. So keys can be anything that is hashable, like a string or integer or tuple, but not a list. A key cannot be a list because a list is not hashable. And the values can be anything. So let's take a look at some examples. Let's set a user equal to name Sally, age 26, marks none. Let's take a look at her name, Sally. There's some iterable methods we can call to find out the items or the keys or just the values. We can also index the dict to find out what value is at the married index for this user dict. So we're going to set it equal to true. Now if you notice, married is not in the dict, but we can add it, and now it's there. So we can use the same syntax to modify. Add and modify, it's the same syntax. So if it's not there, it'll add the item. So married was true, and now it's false. And we can also update the user. We pass it another dictionary. And we're going to change. We can add things this way. We're going to add likes. Likes does not exist. We're going to change marks, and we're going to change married. So now you see marks is now 1. It changed from none to 1. Married is now true. She got married again. And now she has 305 likes. So we can also delete an item. So we want to delete the marks, or we want to delete the marks item. So marks is 1, but now it's gone. Remember, these are all in the same order we put them in, because I'm running 3.6 with this and the C Python reference implementation. We can also clear out a dict, and it'll just be an empty dict now. If we no longer need a specific dictionary, we can use del to remove the reference from the symbol table so we no longer have access to it, and then the garbage collector will be able to free up that memory next time it runs. So delete user, and now we can no longer access it. And this is true for any variable. You can delete any variable, not just dicts, lists, or objects, or anything. Alright, so finally, let's talk about NumPy. So lists are very useful, but they're very slow. And NumPy is orders of magnitude faster. I don't know, 50 times faster than lists or something. Quite fast. It's a well-known package. It's the fundamental package for scientific computing in Python. It's a fast and versatile n-dimensional vectorized and indexed de facto standard for array computing today. Basically, it's Python lists on steroids. NumPy has array functions used to store lists of numerical data. The elements of NumPy are usually numbers, but can also be Boolean strings or objects. Other objects, when the elements are numbers, they must all be the same type. They must all be integers or floats. So there's a number of functions for creating arrays. And the first one is to use the array function. You pass it an iterable, so it'll convert this list to an array. This will convert a Python list to a NumPy array. And that looks like this. And they're all 64-bit integers. And if we pass it all floats, then it will also see there's 64-bit floats. So linear space function will, with the arguments we've passed it, it will create 9 numbers evenly spaced from 0 to 2. Log space will do the same thing. We're going to create 4 log numbers evenly spaced from log 2 to log 3. And we can run arrange to arrange the first 15 numbers. And then after on that, we can also run reshape to make it pretty like this 3 rows. Zeros, we can create zeros. The default is float. Ones, we'll create an array of ones. And last, collections. Python's collections module implements some nice data structures which will help solve various real-life problems. So if we import collections, now NumPy needs to be installed with pip, or however you want to install packages. But collections is part of the standard library, so you just go ahead and import it without installing anything. But you do have to import it because it's not a built-in. So we import the collections, and then we can run collections on a counter of this string, and it'll count how many times each one appeared. So we have 3 A's, 2 B's, and a C. Default dict, very useful. The default will be a list. This is the factory we'll use to create defaults. If it encounters them, it will not error out. It will give us a list. So we can create a default dict. There it is. And so it's empty. It's basically that. And we can just say d sub 1 append. We don't have to say d sub 1 equals an empty list and then d sub 1 dot append. We can just say d sub 1 dot append. There it is. We can, so d sub 2, so the index 2 is not in here, but we can reference it. And the default is list, so it gives us a default empty list. And now once we, just by accessing it, we're not assigning to it, we're just accessing it. Now it's in our default dict. Alright, so the assignment is to use all of these things together. And when you use a list, convert your list to a NumPy array. Alright, so boys and girls, that's it. That was it for containers. Next time we're going to wrap up with working with arguments. Alright, so I hope to see you back for the last session. So that'll do it. Alright. Thank you very much.